Thank you, David, for the introduction. Hey, everybody. This is Neeraj here. So first of all, I would like to thank everybody for joining this particular session, which is Foundation to Apache Spark. And as David mentioned, this is basically a two-part session. So today we have the first part of this particular series, and next week, probably same time, we're going to have our second part as well. I'll share the details about that in the end of the session as well. A bit about me. I'm working as a data scientist at Expedia Group, and here are my LinkedIn and the Medium profile. If you want to look at it, I have posted quite a few blogs specifically on the Apache Spark. If you're interested, you can have a look at my Medium profile for those blogs. Now, in terms of the agenda for today's session, so we're going to discuss about what is Hadoop ecosystem, what are the limitations of the Mapreduce, then what is Apache Spark, what are the different important components of Apache Spark, architecture of Apache Spark, then RDD, which is the abstraction provided by Spark, and the anatomy of the job, that how the Spark job looks like behind the scene. Now, first of all, we'll discuss with the Hadoop ecosystem. Now, in order to understand the Hadoop ecosystem, what we'll do is we'll take a very simple example of, let's say, we would like to analyze some logs, and those logs could be your application log, your system logs, or your any other logs which you would like to analyze using the Hadoop ecosystem. Now, what would be the first step we will going to do in order to analyze those logs? So the first thing would be we would like to ingest those logs into the Hadoop ecosystem. And in order to ingest those logs, we would require some tools like, maybe if it's a unstructured data, we can use Kafka or Flume. If it's a structured data, we can use Scoop. Now, once we ingest the data, then we will need some sort of storage where we keep our data, where we store our data. So we can use HDFS, we can use S3 or GCS to store our data. On the top of that, we have some sort of another layer, which is for the resource management, because in the Hadoop ecosystem, we have the different resources, different services. So definitely we need something, some component to manage the resources. So now, few important resource managers are YARN, which stands for yet another resource negotiator, or we can use Mesos with Spark as well. On the top of that, we have the processing component. So earlier we used to have Mapreduce, and now we have the Spark, or I would say the Spark code, which will be our focus for today's session. But the idea for showing this Mapreduce along with the Spark code is to mention that both these are processing component. So Spark, in a nutshell, is a processing component. It's an analytical engine using which you can do your analysis. However, if you would like to store your data, if you would like to read your data, you still need the storage, which could be your HDFS, S3, GCS, or any other storage which is supported. On the top of Mapreduce, there were some tools like Pig, Hive, which can be used. And on the top of Spark core, we have a few modules like Spark SQL, which is basically to process the structured data, Spark Streaming to process the real-time data, Graphics to process the graph-like data, and MLlib to do the machine learning capabilities. And this whole box, which you could see in a little light gray, is called as a Apache Spark. So this whole package is called as a Apache Spark. The idea behind discussing this particular ecosystem is to share the fact that where exactly the Spark fits into the Hadoop ecosystem. Okay, so this is where the Spark fits into the Hadoop ecosystem. And I would like to reiterate the fact that Spark only provides the processing capability. It's an analytical engine, and in order to store the data, in order to read the data, you need some sort of storage. And in today's session, we're going to focus on Spark core, which is the bottommost layer of Spark. And in the next session, we're going to focus on the Spark SQL, which is to process the structured data. Now, let's talk a bit about the limitations of the MapReduce. So it was slow processing speed because it was using disk a lot. We will take a bit of look in upcoming slides. It was majorly meant for the batch processing only, so it was not ideal for the real-time processing, and not even efficient for the iterative processing, because it kind of uses a disk a lot. And with the iterative processing, which is basically the machine learning algorithms, which are generally very iterative modules, so it was not very suitable for those kind of use cases. It was not very easy to use because obviously even the trivial operations were not available in the MapReduce. And if you have worked with the MapReduce, you might have experienced that you need to write a bunch of Java code in order to get some simple things done. Now, what is Apache Spark? So initially it was started at UC Berkeley in 2009, sorry, as a project. It's a very fast and general purpose computing system. Why fast? We'll discuss in the next slide. General purpose, if you look at, if you remember the architecture of Spark, which we see in a couple of slides before. So we have, like in the Spark, we have multiple modules like Spark SQL, ML, machine learning, and the streaming capability. So in a single package, we have these many capabilities. This is why we say that it's a general purpose computing system. This is a very popular for the iterative machine learning algorithms because of the fact that it uses in-memory computing capability, and it has a lot of different libraries available in the machine learning module to use. In terms of the APIs, which is available with Spark, so it provides quite a few APIs like Java, Scala, Python, R, or even SQL, which means that, for example, if you're not familiar with any one of the language, and if you're only familiar with SQL, still you will be able to leverage the Spark framework. You can write your SQL queries, and under the hood, those SQL queries will be converted by the framework, and still your SQL queries be running in parallel. However, if you have expertise in any one of the language, be it Java, Scala, Python, or R, you need not to learn any other language, and you can still leverage whatever expertise you have. For example, if you're expert in Python, you can use Python to leverage the Spark framework. So this is another biggest advantage, that it provides quite a few high-level APIs which can be used. And it has a very good integration with the Hadoop and its ecosystem. Now, we talked about that Spark is in-memory, it provides in-memory computing capability. So what does that mean? Now, in order to understand the in-memory part of it, what we will do is, we will take a very simple example. In this example, what we will do is, we will pick up some data, we will process that data in an iterative manner, and we will store that data somewhere because Spark don't provide any storage capability. So that is a very simple workflow we will try to follow and understand what does it mean. Now, in order to discuss that, first let's check that particular workflow in MapReduce so that we can check the difference as well. So what we will do is, we will read the data from the HDFS, and we will read the data from the in the MapReduce, and it will launch the MapReduce job. That's the iteration 1. It will store the intermediate data onto the disk, and another MapReduce job, the same MapReduce job will read the data from the disk. That's in a iteration 2. Again, store the data onto the disk, and that is again an intermediate data. And let's say this will keep on happening till 100 iterations. After the 100 iterations, you will get your result, which definitely you would like to store somewhere. Let's say we are storing that particular result onto the HDFS. So this is a very simple workflow, but we have discussed in the MapReduce. Now, looking at these two operations, so this operation is write to disk, and this operation is read from disk. Okay, just to make a note of these two operations. Now, let's try to follow the same workflow in Spark. Again, what we will do is, we will read the data from storage just to keep it consistent. Let's say we'll read the data from HDFS. In a Spark job, in the first iteration, but what Spark will do is, Spark will try to keep the data in memory, and Spark job will read the data from the memory in the iteration 2, again store the data to the memory in the second iteration, and let's say this will also take 100 iterations, and finally a result will be stored onto the HDFS. So the two workflows are very similar, but if you look at this operation, this is write to memory and this is read from memory. And we know that the latency for working with the disk is very high as compared to the memory, which means that if we try to read or write the data to the disk, the time will be very high, the latency will be very high as compared to the memory. So the time it will take to read and write from the memory is very less. That is one of the major advantage for using the Spark, which makes it faster than the Mapreduce. Okay. Now, another question someone may have, that at one point we are talking about the big data, and on the other hand, we are trying to keep the data in memory. So how those two things go hand in hand? So to answer that question, what Spark will do is Spark will try to keep the data in memory as much as it can. If not, then what it will do is it will try to spill the data to the disk. And obviously, when that spilling will happen, the performance of your Spark application will definitely be degraded. So when we are writing an application, we will try to keep our application in such a way that it will try to keep the data. We will filter the data early, we'll try to select the columns, or we'll try to select the data, whatever is needed to keep the data in memory. Spark also have their own memory management systems, which it will use to manage the memory very efficiently. But if all these things, even after doing all these things, you still have quite a lot of data, so it will spill the data to the disk, but your job, your application, Spark application will still be run. Now, some of the important components of Spark is, I'll start from left, the driver. So that is the master. So it works in a master-slave architecture. So your master is driver, and within that, there is a component called as a Spark context, which is the starting point of our Spark application. Okay, and on the right, you have worker nodes, and inside the worker nodes, you have a lot of executors, which basically process your data. And then you have something called as a cluster manager, which basically manages the lot of resources which is required for the Spark application. This cluster manager could be standalone cluster manager, which is a default, comes with the Spark, or it could be Yarn or Mesos, as we discussed in a couple of slides ago. So these are some of the important components of Spark. Now, this is the architecture, a very high level architecture of Spark. At the bottom, we have the Apache Spark, or we can sometimes you also call it a Spark core. On the top of that, we have the different modules: Spark SQL, graphics, machine learning, and streaming, depending on what kind of problem we are trying to solve. And we can obviously use multiple libraries together. For example, if I take the same example of logs, so you can read the logs which are generating using the streaming module of it, which you can read your logs in real time. You can process those logs. Then you can dump those logs into, let's say, some sort of Hive tables, which you can use to analyze. So you can use Spark SQL along with that to read the data from either Hive table or any other storage where you have stored your logs, and you can analyze those. Or if you would like to build some machine learning algorithms on the data to do some prediction, you can do that as well. So the idea is you can use these modules together to build a very efficient and a nice application. Now, if I talk about the bottommost layer, which is Spark, Apache Spark or Spark Core, the abstraction which is provided by Spark Core is RDD, stands for Resilient Distributed Data Set. Now, what does that mean? Let's talk about from right. So this is a data set, which means that this will contain the data. Distributed, which means that whatever the data it contains, it is distributed across the different nodes, whatever we have. Resilient means it will be resilient to the failure. We'll discuss in a bit about the resiliency, but let's discuss about the distributed and the data set part of it. For example, here, even for the example or for the demo, I will going to use the Python API. So this is a very simple Python list. And what we are doing is we are creating an RDD based out of that particular list. SC stands for Spark context, which is basically the starting point of our Spark application that lives in the driver. So let's say we have some function called as a parallelize, and we are trying to create an RDD based on this particular list. Now, when this particular RDD will be created, so this is how your RDD looks like behind the scene. Now, the architecture is you have one driver and let's say you have 3 workers. So you could see your data is distributed across the 3 different nodes. So here, num is your RDD, so basically this is a data set which contains the data distributed because your data is already distributed to the different workers. So what is num here? It's just a reference to the data which is distributed across the different nodes. So this is what we meant by RDD. Now, let's talk about the operations which you can perform on the top of RDD. There are 2 types of operations which you can perform on the RDD. One is transformations, another one is actions. Transformations works in a lazy fashion. Some of the transformations you could see on the screen are map, filter, join, flat map. And some of the actions are count, collect, first, take. We'll see in the demo how they works. I will also share some of the resources and at the end for you to go. But transformations all works in a lazy fashion. What does that mean? So let's take a very simple example. I mean, typically this is the example I used to take pretty often to explain this particular concept. So let's say my manager has given me some task, and let's call it as a task T1. So he gave me, let's say, to create some presentation. Okay, and let's call this particular example. Let's call this particular task as a task T1. And since I'm lazy, although I'm not, but consider that I'm lazy in this particular context. So I just listen to my manager, and I just say yes, I will do, but I haven't started anything yet. After some time, what he asked me is to make some changes to those particular to that particular presentation. So yes, I listen to him, and let's call these particular changes as T2. But since I'm lazy, I haven't started working on that presentation yet. Now, after some time, he changed his mind and he asked me to revert those changes, and let's call those revert of a changes as T3. Still I'm lazy, which means that I haven't started working on that particular presentation. After some time, at the end, he asked me to give me the he asked me to share the presentation. So as soon as he asked me to share that presentation, that acts as an action on me. Although I'm lazy, it doesn't mean that I don't want to work. So at that point of time, what I did is I have started following the instructions from him to create a presentation, do the changes, revert the changes, and I will definitely hand over the presentation on time. However, with this particular approach, the benefit is I need not to perform the task T1 and T2 because I know what all the operations I need to perform, and I can optimize based on those operations. Okay. In a similar manner, this also works. So when you perform a lot of transformations, actually nothing will going to happen behind the scene onto the Spark. I will demonstrate that in my demo as well. But as soon as you perform an action, all your transformations will be executed, and then at the end, your action will be executed. That is what we meant by transformations are lazy. Let's try to understand first with an example and then with a demo. So let's say this is a very simple Python code. What it will do is it will create a Python list. In the second statement, which is in yellow, it creates an RDD. In the third statement, which is in green, it filters that RDD and create another RDD. And what we are extracting, we are just trying to extract the even numbers from our list. And at the end, we are doing a collect operation so that we can display that result. Now here, this parallelize and filter, both these are transformation, and collect is an action. Okay. Now, let's say that when you try to execute this, what Spark will do is Spark will try to create a DAG, which stands for directed acyclic graph, behind the scene, which it can refer later on. Now, let's see what is DAG, directed acyclic graph. So when you create a list, what it will do is it will keep those instructions in a directed acyclic graph. So let's say you have created a list, you have performed some transformation, and you have created an RDD. Then you perform a filter, you create an even RDD. So let's say you wrote these particular, you submitted these 3 instructions to create a list, create a num RDD, and create an even RDD. Although you have submitted 3 instructions, behind the scene, till this particular white line, which you could see on my screen, trust me, nothing has happened on the Spark cluster. Nothing has happened on the Spark cluster. Now, as soon as you say collect, which is an action, what Spark will do is Spark will refer to this particular blog. It will create a list, create an RDD, transform your RDD to num RDD, and it will give you the result. This is what we meant by the transformations or the laziness of the transformation. So let's take our example. So let's say we have created an RDD which looks like this. Now, when we perform the second operations, or I would say when this green statement will be executed, which is the filter operation. So when this particular statement will be executed, so whatever the function you have written inside the filter, that will be applied on each of the partition. So that will be applied on this 1, 2, 3, 4, 5, 6, and 7, 8, 9, and you will get the result. So you could say you are doing the processing in parallel. Whatever the function you have specified, that is being applied on each partition in parallel. And you got some result, again, it will return another RDD. So you could see, even if you look at the content of the even, that is distributed across the different nodes, and again, even is another RDD. An important property to note here for the RDDs are immutable in nature. RDDs are immutable in nature. You cannot change the content of the RDD. However, you can transform your one RDD to another. For example, we have num RDD. We can't change the content of the num, but we can transform using some transformation to another RDD. Now, we got the result. We got the even numbers, what we were looking after. However, that data is still onto the different workers. So in order to collect the data, let's say in this particular case, we would like to display that data onto the console. So you can use the collect operation that will collect all the data from the workers to the driver. However, you have some other operations to save the data to the disk or in any other formats as well. But this is how the RDD looks like behind the scene. And when you perform the operations, this is what we meant by the transformations and actions, where the transformations works in a lazy fashion and actions works immediately. Okay. Now, the last thing in terms of the presentation is the anatomy of the Spark job. When you submit your Spark code, that will be your Spark application. And for each particular action, it will create a Spark job. And your Spark job will be further divided into the stages, and your particular stage will be further divided into the task, which is generally corresponding to your number of partitions to your RDD. And Spark is the most granular component, which definitely be running on your Spark, in your Spark cluster. So that is the most granular component, which is basically running, and that is task. Okay. Now, with this, I'm done with my presentation. So let me quickly jump onto my demo. So just give me a moment. Let me just try to pull up my demo. So just to mention that in order to perform a demo, what I'm doing is I'm using GCP, which is the Google Cloud platform. Okay, so are you able to see my screen?
Yeah, all good.
Okay, great, thanks. Now, so for the demo, as I said, I'm using GCP, and it provides the Hadoop, managed Hadoop, which is the data proc, and which provides the Spark. and I'm using Jupyter Notebooks for my demo. However, there are different ways you can use Spark. You can use Spark with, let's say with the AWS, you have EMR, with the GCP, you have Dataproc. You can install your Spark locally. There are other distributions as well, which are available, which you can use. In terms of the usage, you can use Spark shell, which is the command line to run your Spark code. You can use Jupyter Notebooks, you can use Zeppelin Notebooks, you can use Databricks. So there are a bunch of different options available to run your Spark code. In this particular session, we are using a Jupyter Notebook. Okay, now, so the first thing is, what I will do is, I will create a Spark context, which I mentioned in my presentation that this is the starting point of our application. So I have created a Spark context. Now, before I discuss some of the transformations and actions, I would like to demonstrate the lazy behavior of it. Okay, now here what I'm trying to do is, there is some file present onto my Google storage bucket, and this file, which ends with, like, the name of the file is lang123.txt. This file is actually not present onto the bucket. Okay, so this file is not present at this particular location. Let's see what will happen when we try to run this. So if you could see, I have run this particular cell and I haven't received any error. Okay, which is good. Now let's try to perform some transformation. So map is a kind of transformation I'm performing on this particular file RDD, and I'm generating another RDD, which is RDD1. Let's try to execute this. So in order to do the execution in the Jupyter Notebook, either you can do a shift enter, or you can click on run here as well to execute that. Let me do a shift enter. So you could see you got some number, which means that you have successfully executed that particular cell as well. So you got RDD1. Now let's do another transformation with the map and create an RDD2. Now you could see here, we have read the file, we did some sort of transformation, we did another transformation, and we haven't received any error yet, although the file is not present. Why? Because we have only performed the transformation, which works in a lazy fashion. So actually till this point of time, nothing has happened onto the cluster. Now let's try to perform an action. So count is a kind of action. Let me try to perform an action. Now, as soon as I perform an action, what it will do is it will refer to the DAG which it has created behind the scene, and it will try to execute this particular first statement. And at that point of time, it will try to read the file. Let's look at the error and see what we have got. And you could see input path does not exist, because at that point of time, it will try to read the file. Since the file is not present, we are getting an error. So that is the demonstration of the lazy behavior of the transformation. Now let me change this to a file which is present. So now the lang.ext is present. Now if I try to do a count on it, then definitely it will return the count of the elements in the RDD, which is 5 in our case. Okay. Now let's try to create an RDD based on a collection. So in our presentation, we created an RDD based on this Python list. So let's try to create an RDD. And so here I have printed the type of the num RDD just to demonstrate that this is an RDD. And if you would like to check the elements of your RDD, you can perform a collect operation and you can check the elements of your RDD. Okay. Now let's try to perform some of the transformations. So let's perform a map operation. So your num RDD contains the number 1, 2, 3, 4, 5. What map will do is map will map each element of your RDD to some sort of output. Now that mapping, how you would like to do that mapping is something you specify inside the map, either as a named function or a anonymous function or a lambda function. So here we are specifying as a lambda function. So what we are saying is for each element, return the element multiplied by 2. So what we are saying is for each element, just double that element. So you could see for the num RDD where we had 1, 2, 3, 4, 5, we have doubled those numbers and we have got 2, 4, 6, 8, and 10. So this is how the map works. Filter As its name suggests, it will use to filter your elements, and how you would like to filter. You can specify your expression. So for each element, take the modulo with 2, and if it's equal to 0, which means that return only the even numbers. And you could see we only got even numbers out of our num RDD. So if you look here, we are performing this on num RDD, which contains the number 1, 2, 3, 4, 5. And these are the only 2 elements which are even. Another function is a flat map. Now the flat map will work very similar in a very similar manner of map. It's just that it will flatten the structure to one level. What does that mean? So first what we will do is we will perform a map operation, and for each number we will generate a range from 1 to that number and see how it looks like. So if you look for 1, we are generating a range 1, 1, which is empty. Then for 2, we are generating a range from 1, 2, which is always 1 because the last element is not inclusive. So this is how it looks like. So we have mapped each element to some sort of range. And if you look here, this looks like a list of lists, which is okay if we need that. But what if we want all the numbers, but instead of list of list, we only want list? So we can perform the flat map operation. And if you look here, the numbers or the elements are exactly same. It's just that instead of list, we only received a list because it flattened the structure. Distinct, as its name suggests, it will only return some distinct element out of it. Let's discuss reduce by key. So reduce by key, as its name suggests, it will work on a key value pair, okay, where the first element will be the key and the second element will be the value. So let's say we will create an RDD based on the key value pair. So here A is a key, 5 is a value, B is a key, 7 is a value, and so on. So this is the content of my RDD. Now when you perform a reduce by key, when we perform a reduce by key, we can understand this particular operation in the 2-step. So first is, for a particular key, it will collect all those values. For a particular key, it will collect all the values. So for example, for key A, you have some value 5, some value 3, and let's say if you have few more, so it will collect all those values for a particular key. So after, let's say, the first phase of reduce by key, you got this where you have the key and you have all those values. Now in the second phase, what it will do is it will perform some operations on this particular collection of values, and that particular operation is something you specify inside the reduce by key. So here what you are saying is, for each 2 values, just multiply those values. So if I run this, you could see corresponding to B, you have 7 or 1. So 7 multiplied by 1 is 7. So corresponding to B, you got 7. Okay, yeah. For A, you got 5 and 3. So 5 multiplied by 3 is 15. For C, you got 2 and 4. 2 multiplied by 4 is 8. Okay. And let's say if you would like, instead of multiply, if you would like to do add, so you can perform that. So the idea is the reduce by key works in 2 phases. In the first phase, it will collect all the values corresponding to a particular key. And in the second phase, it will perform an operation based on that collection of keys. So similarly, you have a lot of other operations like group by key, sort by, which you can go through it as your own pace. I will also share this particular notebook and some of my blogs which talks about this because we have quite a lot of different operations, but to give you a gist at how it works. Now, in terms of actions, actions are fairly simple. So for example, if we create an RDD, one action is count, which will basically return the number of elements within the RDD. Another one is, let's say, first, which will return the first element out of RDD. Collect, which will return all the elements from an RDD. However, we should not use the collect operation in production, because when you perform a collect operation, what it will do is it will collect all the data from all the partitions and return to the driver. So we are talking about the big data. So if your data, if you're running in the production, which means that you're running on a very large load, if you perform a collect operation, which means that you're trying to collect all that large data into a driver. So first of all the data has to travel across the network. That will degrade the performance of your application, and all the data need to reside in your driver. That may cause out of memory error as well. If not, for example, if you have, large enough memory to keep the data, but certainly your driver will be overloaded and the performance of your application will definitely be hampered. So what you can do, if you would like to check the content of your data, instead of collect, you can perform a take. So take 2 means it will only return the 2 elements. Take 3 means it will only return the 3 elements. So at any point of time, if you would like to check the sample of your RDD, how it looks like, you can perform a take operation and you can check the content of your RDD. Now with this, I would like to end my presentation, but there are a few bits I would like to share. So first of all, whatever we discussed here in today's session, so I have also written a blog corresponding to that. So let me just pull that up on, sorry for that. Okay, here. So start your journey with Apache Spark part 1. So whatever we have discussed is covered here. So we discuss about the architecture. We discuss about how we create an RDD. We discuss about anatomy of the job, and we discuss about various transformation, which you could find here. It also has a link to my GitHub notebook, which you can refer. And I have also kept the link for the official documentation, which definitely, if you would like, you can go through it. In terms of the next session, this is what the agenda for the next session is, that we will going to talk about how we can process the structured data, which is the data frames, which is very similar to the relational tables. So what are the different operations which we can perform on the data frames, how we can read the data from the Hive table, how we can save the data to the Hive table as a different types of Hive tables. If you have worked with managed Hive table, partition Hive table, external Hive table. We will also discuss about how we can work with the CSV file, how you can read your CSV file, process that into a Spark, store your result again to the CSV file, how you can read or write with the Parquet file as well. So these are some of the topics which we would like to discuss in the next session. So feel free to join us in the next session if you see that this is something which is of your interest. So now I would like to thank everybody for joining this session, and maybe I'll hand over to David for any questions you might have. David, now it's over to you.
I am back, mate. Thank you. Thank you very much, man. And I think that the takeaway, that the structure that you've put into getting this content across is fantastic, and actually having these additional resources pre-prepared that people can follow up with between the sessions. Yeah, mate, really thankful for, thank you very much for that. In terms of the questions, we have got 3 or 4 questions which we'll fire through now. We'll run through them as I mentioned before, Neeraj. I'll ask them in advance and we'll get them answered. If I could ask, maybe just stop sharing your screen. I think that might actually make it for the people connected in just to be able to see the 2 of us, which I'm not sure if it's a blessing or not, to be honest, mate, but they get to look at the 2 of us, man. So we'll jump into the first question we have here. It's from Christopher. Christopher's asking specifically about NLP on Apache Spark, if you have any more information on that. And he was also asking if it's possible to integrate with Neo4j.
Okay, so there are 2 questions. First is, can we do NLP on Apache Spark? Yes, you can, in a way, write your application and you can perform the NLP on Apache Spark as well. And obviously, if you want, you can also try to use other libraries which are available, which can be integrated with Spark to do that. The second part of is it possible to integrate with Neo4j? I mean, to be honest, I haven't worked with the Neo4j, but based on some of the readings, I think it's possible to integrate Apache Spark with Neo4j. But to be honest, I'm not pretty sure. So, I mean, I would like to be honest on that part.
Hey, that's perfect. Makes sense. Thank you very much. Next question from Adam. He was asking what sources can we use to store the data for Spark?
Okay, so in terms of what sources you can store data for Spark, for example, if you're using AWS, definitely you can use S3. If you're using GCP, you can use GCS buckets. So these are the blob storage or the object storage. You can use Hive. You can create, you can store your data as a Hive table, or it supports the different other formats as well. You can store your data as a CSV, as a JSON, Parquet, Avro, and few other formats as well. So yeah, I mean, these are the data sources which, I mean, probably you can use to store the data. I mean, if that answers that question at all.
Fantastic, we've got that covered then. Next question from Addy. Good to see you, man. Addy's one of our previous speakers, and actually he's going to be delivering a workshop for us as part of the main data science festival. So yeah, good to see you on today. He was asking, it's quite a long question, so please do read along with me. I'll flick that over to answer live. He was asking, during your initial demonstration of the performance improvement of using Spark versus Mapreduce, you indicated that during the processing iterations, if the in-memory storage of the data in Spark is exhausted, the data will spill over to disk. He's then asking, is it possible to instead for the workflow to provide the data from the source to Spark via lazy loading, i.e. yielding a small subset of data chunks iteratively?
So if I mean, understood your question, so it has two parts. So first is like, it will spill the data to the disk, which, yeah, I mean, kind of you have agreed to that. And the second is it possible to instead for the workflow to provide the data from the source to Spark while is, yes, absolutely. So, I mean, so what will happen is when you try to, let's say, load the data, so Spark will load the data lazily. It won't load everything. It will definitely load the data lazily, but whatever the data you have loaded lazily, even if Spark won't be able to keep that data in memory, then at that point of time, it will spill the data to the disk. So that is very important. For example, when we are working with the large data, so it's important to filter the data at an early stage. It's important to select the data at an early stage so that we are only targeting to the data which we are interested in, so that that can be fit into the memory. There are, in terms of the memory management, there are a few things which we can perform in the Spark application with some of the flags which is provided by the Spark. By adjusting those flags, we can do a bit of memory management. And however, Spark also does its own memory management, which helps us to keep the data in memory as much as it can.
Thank you very much, man. I'm going to jump to the next question from David Newman, because it's quite a straightforward one, actually. He was asking, where can we download the presentation? So I believe you've got quite an active GitHub and stuff like that, have you? Or can you download this presentation?
Yes, absolutely. That is available. And I think we will share the link for the presentation and the Medium blogs as well, where you can find, I mean, all the stuff we are talking about.
Perfect. So yeah, we'll follow up, David, with an email to everyone that attended. So we'll get that one across to you. Another question from Adam. He was talking about programming with Spark. Obviously, you can work with Java, Python, Scala, or R. What would you recommend? Is there recommendations or different use cases?
So, I mean, to be honest, I mean, I used to get this particular question a lot, and I start my answer with that, like, I can't say any answer to that particular question, but what I can do is I can share some facts which can help you to pick up which one you would like to use. So the first part is, let's say if you are familiar with Python, then definitely you should choose Python, and so that you can focus more on Spark rather than learning a different language. So if I'm expert in Python, I would definitely like to choose the Python. If I'm expert in Scala, it makes sense for me to choose Scala to use the Spark framework, because under the hood, the performance is relatively same. However, if you are new to all of these, which one you should go for it? So, I mean, it's the Python and Scala, which is basically, which is more widely used into the industry. And even like for large applications, it's maybe the Scala if you are learning more. The fact is, most of the Spark code is written in Scala. So that is something which I can share, which might help you to take that decision. But again, for example, if I'm leading some particular project and I have got the Python expertise, then definitely I would not like to go with the Scala, because I don't want to have that learning curve, at least in my project. That's what my understanding is, but you may have other thoughts. But these are some of the facts I can share with respect to that particular question, if that helps.
Perfect. That definitely does. Thank you very much. Next two questions are from both from Richard Dunn. He's talking about, if you're new to Spark and you're learning Spark, have you got any tips about the cheapest way to do it? He was kind of saying that, for instance, with Databricks, you get a 14-day trial, which isn't particularly long. Is there any tips for people starting out to get going with it?
Yeah, absolutely. So, I mean, there are quite a few. So, for example, if you would like, what you can do is you can install your Spark locally, and you can run your Spark applications locally. If you want to integrate with Jupyter Notebooks, there are tutorials where you can install the Jupyter Notebooks and run your code into the Spark code into the Jupyter Notebooks. Then everything is running locally. You need not to worry about anything, any cost or something like that. However, still, if you would like to explore these options onto the cloud, I mean, every cloud, for example, provides some sort of free resources. As you mentioned, Databricks for 14 days. Similarly, GCP provides like, I think, $300 per year on your new Gmail account, on your new Google account. So you can leverage that. I think that is pretty decent. You can launch your Dataproc cluster. You can work around with Spark. So eventually, if you look at today's my presentation, I was doing on that GCP only. So you can do that. And yes, I mean, there are plenty of resources. So if you are doing it locally, then you're not paying anything. Even if you are doing on cloud, based on cloud provider, they are providing some free resources which you can use.
Okay, perfect. Thank you very much. This is what I thought may happen, actually. So now that we've started answering a few questions, we've got an absolute flood of questions coming in. So we've got about 10 minutes left of the session. So we'll do our best to fire through everything. Next one was from Adam, but I think we'll skip past that because Adam's had a couple. And we'll go to the question from Nora.
I think that
Nora
has
had a
already
specific...
been answered, David. That question.
Say again, sorry?
That question has already been answered earlier. So.
Perfect. Thank you very much. Next one then, in that case, from Lee Hawthorne. Is it possible to load a truth table to Spark to use in algos, kind of like a temp SQL table?
Okay, so a very short answer is yes. How to do it? Please join me in the next session.
Oh, I love that. Fishing. Well done, man. Next question from Sean. Great to see you on, Sean, actually. I wish we were doing things live and got to see all you people in person. Can Neeraj recommend any troubleshooting tools for Spark?
Troubleshooting toolings. I mean, troubleshooting performance improvement is always a topic of very much interest. I mean, maybe in the next session, I can try to share some sort of techniques, how to do that. There are, I mean, quite a few tools which are available into the market. You can, I mean, the open source project which can help you. But I mean, there's not any which I would like to, recommend at this point of time. But in the next session, I can share some of the tips that what you should be careful about when running your Spark application. For example, I have mentioned that if you're running your Spark application, when we were looking at the collect operation, we should not do that into the production environment, because obviously that will overload our cluster and hamper the performance.
Thank you. Thank you. I'm going to shoot down to the question from Dave Mason now. Dave was asking, at what sort of level of data volumes is it right to use with Spark? Is it efficient on small volumes?
Typically, these are the big data systems. I mean, if you want, you can use it on small volumes, but typically these systems are meant to be used for the large volume of data. But I mean, yes, I mean, if it can work with a large volume of data, you can absolutely work with a small volume of data as well. So, yeah.
Fantastic.
But typically, these systems are designed for the large volume of data.
The next question from Abul Fazal. They're saying that they're a data scientist. Is it necessary to know Apache Spark? Asking that question because they haven't used Apache Spark yet without having any problems.
So, I mean, this is, I mean, obviously, irrespective of whatever you use, like into the technical world. I mean, we always get into the problems which we are trying to solve on a day-to-day basis. But to answer your question, it's not absolutely necessary to know the Apache Spark to become a data scientist. Definitely, there are a bunch of other tools and the libraries which are available, and data scientists obviously is a you can you can do only with the Python as well. You can do with some other languages, but it's just that when you are working with the large data sets, it provides the capabilities to do the things in parallel. But yeah, you can use other tools as well. If you like.
Fantastic. Thanks, Neeraj. We'll take the question now from Alan Joel. The first question, he's done well here actually. He's asked about 8 questions in one. So the first part you've already covered, definitely. The next part, lots of stuff about performance. So I don't know actually, perhaps Neeraj, if you want to have a little skim read of that and give any takeaways in terms of performance in working in that way.
Absolutely. Just give me a moment. I'm just trying to read that. So.
I believe everyone that's watching along on the webinar actually will be able to see this question that we're looking at the moment as well.
So in terms of the language, I have already talked about it. Mm-hmm. So the second is, okay. So in terms of the second, can I go with one driver? So you always have one driver in terms of workers. If you would like to one worker, which means that you're not doing things in parallel. So because if you use the multiple workers, you can leverage the parallelism of it. That will improve the performance of your application. For the sake of running, if your worker is good enough, one, you can do that, but that is not recommended way. So, and regarding the size of the cluster, that always varies upon like what is your size of the data, and also what is the size of your cluster as well. So, I mean, that's a bit a tricky question to answer straightforward, that for this much of data, you would like this much of size. So that's something, I mean, with time, you have a better understanding. But definitely, driver will always be one, and worker one is like not recommended because you won't receive the parallelism in that case.
So when it comes to defining the number of workers, is that down to you to decide and fine tune? Because I guess it would depend quite a lot in terms of the type of data and the type of queries being run and stuff like that. And is it just trial and error, or is there certain benchmarks or guidelines that you follow when you're defining the number of workers?
So the number of workers are like depending on what kind of data size you are trying to solve and what your size of each worker. So like what memory capacity your particular worker have. And then definitely you do a bit of hit and trial and trying to figure out the number of workers, which you can always adjust while submitting your Spark application. However, in terms of the number of cores or the total number of cores within the workers or for your Spark cluster, it should align with the number of partitions so that your each partition can go into one core and you do a processing, and you can get maximum out of your cluster.
Perfect. Thank you very much, Neeraj. In terms of those final questions, there was a couple more, but I think sadly we're running out of time a little bit, and a couple of those questions were perhaps a little bit more generalist. So we'll save those perhaps for another time. We've just a couple of minutes to go, actually, Neeraj. I know you've finished up with your slide there, last slide, but if you could, just a quick 60 seconds on what you'll be covering next week, just before we finish up.
Yeah, absolutely. So in the next session, so today we discuss about the architecture, how it works under the hood, which is very important. In the next presentation, I will going to cover the structured data, which probably everybody mostly be interested in, that how we can read the data, and then how we can process the data into Spark. And once we do the processing, definitely we can't keep the data in Spark, but what are the different sources we can save our data to the Spark, and what are the different ways we can do that. So these are the things, and pretty much it will be around the structured data only.
Perfect, mate. Sounds really, really good. So what we'll aim to do, obviously we've recorded this session. We'll aim to get it onto our YouTube channel in the next day or two. So actually, if people want to recap just before joining next Thursday, they'll be able to do that as well. So once again, just to wrap up, thank you very much, Neeraj, for giving up your time to come and join. Thank you to all of you guys at home for joining. We've had a number of comments already saying how much you loved it. So really been a beneficial session. So thank you very much, Neeraj, and we'll be back next week.
Absolutely. And thanks everyone for taking time and joining for this particular session. Thank you.
Perfect. See you next week, guys.